Hi, welcome back to Engineering Drawing. I'm your Dr. Vasu. Hope you are enjoying the lectures on engineering drawing and other subjects. If you want to learn this and many more interesting topics, please do subscribe this channel. If you like this video, please hit the like button. And that will keep me motivated to create many such videos in the future. Now, let's jump right into the topic and see the way of drawing a cycloid. Okay. So, a cycloid is one where if you take a circle, suppose you take any tire of a vehicle, right? Tire, why I said tire in the sense, it should touch the ground. Suppose I take a cycle wheel, and we have a straight road here, and this cycle wheel is moving on the road without slipping, right? When it is moving on a straight road like this without slipping, I take some point here on the wheel. This is on the wheel here, a circular wheel. How this point is moving is observed, right? Just observe the point moving. It's coming up, right? Slowly, as the cycle wheel is moving, the point is coming up slowly and again going down. In one complete cycle, in complete one rotation of the wheel, we are getting this point going up and again coming back and touching the road. Now we are going to trace the path taken by this point, right? Starting from one end to the other in one complete cycle of the wheel. Now let us see how to draw this. So when it is completing one complete cycle, the distance traveled by this is the circumference of the circle. So let's take a length of the line which is equal to the circumference of the circle. The circle radius is given, and here the 2 pi r is marked here, and I'm marking as AB, the length, that is 2 pi r. Now, this is the center of the circle. Now, I take a point P here on the circle. The point P is on the circle. Let us assume that this point is moving slowly. So for this, I divide this circle into 12 equal parts, right? But generally we should take 12 parts, but for convenience sake, I am taking only 8 parts here. If you take many number of points, the curve will be smooth and will be good. So here I am taking only 8 parts. So name them as 1, 2, 3 in this direction, right? 1, 2, 3, 4, 5, like this. So now I take this point, right? I divide this line AB into the same number of equal parts, right? AB is into same 8 parts here in this case. Name them from A as 1, 2, 3 like this. All the points are marked. So 8 points I got it. So these points we have marked it as 1 dash, 2 dash, 3 dash like this. The meaning of it is when the circle is rolling, this points and C will be moving at the same height. There won't be any change. And when it moves a bit towards right side, this point 1 dash comes in contact with the 1 here, because we have divided this circle into 8 parts, and which is equal to this length here. The circumference is equal to this much, and each part here is equal to this curved length. So when the circle point center is moving to this position, 1 dash comes in contact with 1 here. Okay. Similarly, when it moves further, 2 dash comes in contact with 2 like that. So, and the point C is moving at the same height. That's why I drawn a line here at through C, and taken the points here at the corresponding to these points 1, 2, 3 like this. I have taken the position of this center, right? The position of the center is moving to different positions here and named them as C1, C2, C3 like this because they are it is the center. I'm calling it as C1, C2, C3. Now I'm drawing lines, horizontal lines through this 1 dash, 2 dash. Of course, it is coinciding with the center line, 3 dash, 4 dash, like this, 5, 6, 7, right. Now, let us see the circle moving towards right side. How? The C comes to C1 position. By the time C comes to C1 position, it is traveling this much distance and this point 1 dash comes in contact with 1, okay, and what happens? Coming to this point P on the curve here, on the circle, this point 1 is coming down by this much distance, whereas this point P comes up on the other side here by this much distance, okay. The point 1 comes down by this much distance. Point P at the same time is moving up in this side by the same distance. But in the same time, it is moving towards right also. So the circle is occupying C1 position. Center has come to C1. Now the point P has come to this position. Point P is always at the radial distance. The radius of the circle is, say, suppose R. At the same radius, the point P is coming up to this. That's why through 1, we have a line. With the C1 as center, with the radius R as radius, we intersect this horizontal line at some point and we call it as P1. Now, the circle is still further rolling. C1 comes to C2 position. 2 dash comes and occupies 2, right? The point 2 is coming down by this much distance means the point P, which is at the bottom, will go up by the same distance. So the circle comes to this position here, right? C2. The point P comes to this position, this height. Okay. Now what happens? Take the radius of the circle as radius, C2 as center, draw an arc here, cutting the second line, passing through 2 dash. Now, we'll proceed further in the same lines. C2 comes to C3 position, right? We named it as P2. C2 comes to C3, right? And point P now moves up by this much distance because 3 comes down by this much distance. At the same time, the point P on the other side should move by the same height. So C3 as center, we intersect this third line, right, passing through 3 dash with the radius R. Now we get a point here. Similarly, we call it as P3. Next comes to C4. Now the point is on the top, right? It has come down by half of the distance. So C4, when it comes to C4, the radius as R, you draw an arc, you get the point P4 here. Once it reaches the top, it starts moving down because the circle is rolling further. This has come down, come onto the top here. Now it moves slowly towards right side and slowly when C4 comes to C5 position, right? The point P comes down to this height. So it occupies this height here. So draw an arc, mark P5. Similarly, next C6 as center. Now draw 6th line here, arc through 6th point, this 6th point. So draw an point arc here, get the point P6. Still moves further, C7 as center, right? Now with the same radius, intersect this 7th line passing through 7. So get another point P7 here. Now it has come to C8. Once it reaches the end, it has traveled all the 2 pi r circumference length and point P comes down and touches this 8.8. Now it has completed one cycle. We got all the points here, intersection points. We join all these points by a smooth freehand curve like this. When you join all the points by a smooth freehand curve, we get the cycloid. The path traced by a point on the circle here is called the cycloid. Okay. So now, suppose we have drawn the curve like this. Just erased the construction lines. That's it. To be more clear. Now I have the curve, right? I want to draw the tangent and normal at some point on the curve. We have taken some point here, right? From that point, draw an arc with the radius of the circle as radius onto the center line. So this point M as center, we draw an arc here through the pass cutting the center line. From this point, draw a vertical, right? This is the radius we have drawn. From this point, we got a point. From this point, draw a vertical. This intersects the baseline here at N. Join this point N with M. That is the normal to the curve at M. Draw a line perpendicular to this passing through M here, and that will be the tangent to the curve. So like this, we draw the cycloid and also mark the tangent and normal to the curve at any point. You can follow the same procedure to draw a tangent and normal at any point, anywhere on the curve. Okay. So we have seen the construction of a cycloid. Hope you had understood the topic. If you have any queries, any questions, or any suggestions, please do comment, do subscribe the channel. Thank you.